The purpose of this video is to cover client settings and how they impact creating effective security policies. Now, client settings is all about what processes you trust to establish a user's identity such that that identity can be used as a security policy to grant or deny access to the data. Those processes that you trust are the only processes that can be used to establish identity. Any other process that's not trusted cannot be used to establish identity. Now, this issue is primarily impactful in a Linux Unix environment. Let me give you an example. I have files in a directory that are within a guard point that I'm going to create. And I only want to grant access to these files to a specific user or user set. Say, for example, a user called SSH-user. And I don't want privileged users such as root to have access to those files. Well, in a Linux Unix world, it's almost impossible to prevent access. So, for example, I can assume a user's identity by the use of su or sudo. And because I've assumed that user's identity, I then can gain access to the files that I've restricted to just this user. Well, we don't really want to trust that behavior, or we may not want to trust that behavior. And so host settings or client settings is a means by which we could say, no, you cannot assume that user's identity in order to gain access to that user's trusted access of the data. Instead, you have to use an authenticator to do that. So let's look at what authenticators are by default trusted. Again, this is only applicable to Linux Unix environments. It's less applicable to Windows environments. So if you look at client settings, you have a whitelisted set of processes that establish identity. And only if this processes have established identity will we then trust that process to meet the user criteria. Let's look at that just a little more in depth. So if you run pstree on Linux and Unix with a couple options, we can see that every process, or the process tree, that every process has a user associated with it. Now, by default, if you don't see what the user associated with it, then you can assume that that process is running or executing as root. Right? So this is the pstree command I just executed, and so I don't get any distinguishing user, so we know this process was established or executed as root. Well, let me do the same thing, but I'm going to execute it as a different user. Alright, I'm going to do pstree-au, and now you can see that SSHD, which was executing as root, executed and did a set ID for SSH user, and now this branches is now executing as SSH user. Likewise, I could su to SSH user and run pstree and get a similar set of behavior. Notice that SSHD has an executing shell environment. Then I use the su command to assume SSH user's identity, and then I executed the PS tree as SSH user. So it's two methods of becoming that user. One is I logged in as SSH user, and the other one is I assumed that identity using su. Or the sudo would also be the exact same type of behavior. So the real key here is, in one situation, I had to provide this user's ID and password. In this other situation, I did not. And the question is do we want to trust when I trust a user to be who they are when they provide the user, but not trust the user when they're simply executing because they're privileged and they assume a user's identity, which is extremely common. We prevent this behavior by default by only trusting the SSH daemon to set the identity, not su. So if you look at the client settings, you'll notice that SSHD is a trusted authenticator, but su is not. So if su establishes identity, meaning it forks off a process and does the set ID, changing it to a different user, then we will not trust that behavior. And let's show you how that would work in a policy. I'm going to use a user set. And the user that I'm interested in only is identifying. In this case is SSH underscore user name. Alright, now I have a user set that has one user in it, which is SSH user. And I'm going to say that user is going to permit and apply the key. So once I apply that policy rule, SSH user will have access to the data. I'll add one more rule, and I'm going to deny everything else. So if you look at these set of policy rules, what I'm specifying is SSH user gets full access, permit and apply key, deny everybody else. Rule number 1 is just about using LDT, which is not applicable to this video. We'll create a key rule. The data is currently unencrypted, and the data is going to be encrypted with a key my test key. Okay, that should take care of that. So here's a summary. Again, rule number 1 is about rekeying of data. Rule number 2 specifies that the user in this set, which happens to be SSH user, is permitted access. If it's not this SSH user, then it's going to follow rule number 3, which is to deny all the other access. I create a guard point. On that directory, secret. I'll just do the bank directory, so it's secret bank. Let's give that a few seconds to go active. Okay, now the data is encrypted and the rekey has already taken place. Let's go back out and see what access looks like. Okay, let's look at the behavior. And I am currently root. And I no longer have access to the data. and I am SSH user here, and I do have access to the data. Okay, so that's no problem. So what if I assumed SSH user's identity? So now I have assumed that identity, and I'm still denied. So assuming the identity does not grant me access to the data. Right? I have to be SSH user, and currently the processes I trust to establish identity are SSHD and some others, as well as login. So what if I log in directly to the system? First thing to note, I have a different authenticator. So if you notice, there is an authenticator here called login, and it does here and does a set ID to SSH here. So login was my authenticator. Is that trusted? I'll go back out to the GUI, and sure enough, login is trusted. So I should be able to access via that method of authenticated, being an authenticated user. And sure enough, I can. If I log in directly as root, I'm going to get denied. So it's all about establishing identity and who we trust as an authenticating process. So you can see that login forked a process, but it's still executing as root, so there's no set ID, so no change of identity. I am still executing as root. Although I was authenticated, root's not a trusted user within the policy to gain access. Only only the user, SSH user, when they are trusted from a trusted authenticator process.